Okay, so tonight is the last lecture for this subject, and so if you check the examination schedule, I think the examination for this subject will be conducted on the, I forgot, so 17 or 15, okay, and so 2 weeks, around 2 weeks away. Yeah, so for today, I think we will finish today's lecture quick. Okay, so I will first of all explain the solutions to the test, and then I will give you a quick revisions such that you can prepare for the examination. All right, and I am now using Panopto to do the recording as usual. Okay, so it means that after the lecture, you will be able to find the link to this video and then to check the test solutions. So don't take any pictures using your mobile phone, right? Okay, so can we agree to this? So when you need to review the test questions and solutions, just click the link to the recording, okay? So don't take any pictures. All right, so for the test, I think you have the marks. Okay, so you should be able to find your marks in the blackboard. So for the test, I am not going to distribute your answer sheets to you because we have a big class. So I think it is quite difficult to distribute the test during the class. But if you have any questions, or maybe you think maybe I marked something wrong, so after explaining all the solutions, so like maybe you are very confident that you can get a very high mark, but then the result is not as what you expect, maybe you can send me an email, okay, so that I can check for you, or even maybe I can take a picture of your answer sheet so that you can take it for your reference and checking, okay. And for the workshop, I have already marked the workshop, and for the workshop there are only 12 groups, so I think it is much easier for distributing the grade, the assessment to you. So I will explain the solutions to the test first, okay, and then distribute the workshop, the assessment, and then we will have a quick revisions for your preparation of subject. Okay, so for the test, the full mark is 60. So we have quite a number of students getting full mark. Yeah, my surprise, I think that's the best performance over the years. So we have like, I think 3 or 4 students getting full mark. And the lowest mark is like around 15, okay, not too low, okay, so I think the performance is all right. So let's take a look at the section A, the multiple choice. So the first question, and you can see the yellow color would be the answer. Okay, what are the temperature increase limits set by the Paris Agreement to address the climate change? So it should be below 2 degrees C. Okay, we target to limit the temperature rise by 2 degrees C and tried our best to limit to 1.5 degrees C. Okay, and then question number 2, in the context of life cycle assessment, which of the following statements most accurately reflects the considerations involved in conducting a comprehensive environmental impact evaluation? So here is about life cycle assessment. Okay, so for answer A, life cycle assessment primarily focuses on quantifying carbon emissions, often neglecting other environmental factors, which is not true. Okay, for life cycle assessment, it can be used for many different kinds of assessment. Okay, and carbon assessment or assessing the impact of climate change is only one of the application. So you can use the life cycle assessment for assessing like the ozone depletion, or maybe the air pollution, or the toxicity in the soil or in the water, and so on. Okay, so A is not correct. And then B, the interpretation of LCA results can be heavily influenced by the reliability of data system boundary and allocation method. This is true. Okay, so the absolute results of LCA may be very often not too meaningful. Okay, LCA is usually for comparing results. So you use the same method, the same set of data for measuring or for assessing the life cycle value among different alternatives, and then you make a comparison. Okay, the absolute value could have a high level of error. Okay, and then the results of LCA are typically consistent across different studies. Not true. Okay, very difficult to have a consistent study because there are just too many variables, too many data that you need to collect. Okay, conducting an LCA is straightforward and requires minimal data. No, okay, a lot of data. Okay, and then number 3, which of the following carbon emissions is or are included in cradle to site embodied carbon of a building material? Okay, we have different boundary for quantifying embodied carbon. Okay, like cradle to gate, okay, to the manufacturing factory, okay, cradle to site, construction site, and also cradle to grave. Okay, so here it is considering cradle to site. Okay, that is from extracting the material and then transporting the material to the some manufacturing factories. Okay, and then manufacturing and then transport it into some distribution site and then transporting it into construction site. And it should also include the emissions due to material wastage. Okay, like in the lessons, we have tried to do the calculations of embodied carbon, and we have included a wastage factor. Okay, because for cradle to site embodied carbon, we will also include the amount of emissions due to material wasted. Okay, and the construction and site activities associated with the installation also included in the cradle to site embodied carbon. Okay, but not cradle to gate. Okay, for cradle to gate, it's only from cradle to the distributor. Okay, to the distributor of that material. Okay, not including transportation from the retailer or distributor to the construction site, and not including the material wastage or construction and site activities inside the construction site. Okay, but this is cradle to site, so we will include these also. So the answer will be both A and B. And then question number 4. Which type of building typically has a lower cradle to grave embodied carbon? So cradle to grave would be the whole life cycle. So whether a steel structure or a timber structure has a lower embodied carbon is very difficult to tell. Okay, so the answer should be D. It cannot be determined. Okay, because the carbon emissions associated with production, transportation, and end of life differ significantly and can vary based on numerous factors. So just from the material, okay, whether you use steel or use timber, is just too less data. Okay, we don't have enough data to determine whether which structure will have a lower cradle to grave embodied carbon. Okay, how you dispose the steel, whether you recycle or you throw away. Okay, and then the timber, whether you will burn it and then or you throw it to the landfill, or whether you will reuse it. So it will affect very much the cradle to grave embodied carbon. Okay, for cradle to gate, maybe you can determine. Okay, so for cradle to gate embodied carbon, we have some reliable data. Okay, comparing for the same mass of steel and the same mass of timber. Okay, we have some idea. Okay, probably for steel, we'll have a higher cradle to gate embodied carbon. But for cradle to grave, there will be lots of variables. Okay, number 5, why do emission factors for grid electricity generation vary significantly across different regions? Okay, so not necessarily different regions. Just in Hong Kong, the emission factors for CLP and that of HGC already vary a lot. Okay, so it is because the efficiency of different power plants and the energy mix vary by region. Okay, maybe some power plants use more coal, and maybe some power plant use more oil. Okay, then for the power plant using coal, the emission factor will be higher. Okay, because for the coal, when we burn the coal, it will emit more carbon dioxide. Or it may be for some power plants, they may use renewable energy, okay, maybe using PV panel, wind turbine, hydropower, then the emission factor would definitely be lower. Okay, and yeah, impacting the carbon emissions per unit of electricity generated. Okay, and then number 6, in calculating the total carbon footprint of a building, which of the following type of carbon emissions encompass the emissions associated with the transportation of building materials to the construction site? So this is the transportation of building materials, not the occupants. Okay, so it will not be transport carbon. For transport carbon, it would be the carbon emissions due to the transportation and the day-to-day travel by the occupants. But here is about the building materials. So it should be included in the embodied carbon. And number 7, which of the following factors influence the operating carbon of a building? So the operating carbon would be the carbon emissions due to the day-to-day operation. Okay, like the building services system, okay, like due to the consumption of electricity by the air conditioning system, by the lighting, by the electrical appliances, and so on. So these will be all related to the electricity consumption, and therefore the fuel mix of the consumed electricity will definitely affect the operating carbon. So the fuel mix would be whether the power generating company will burn oil or coal or natural gas, or whether it will utilize renewable energy. Okay, these are the fuel mix of the electricity generation. And number 8, if the emission factor for transportation of building materials is 0.15 kg carbon dioxide equivalent per ton and per km. Okay, so this is the emission factor for transportation of building materials, and it is dependent on how heavy is the material and also the traveling distance or the transportation distance. So we need to multiply the weight of the material and also the distance. So 0.15 multiply 5,000, multiply 78. Okay, but be careful, the unit is per ton. And here the weight is kg. So you need to divide it by 1,000 also, okay, so that you can convert the unit from kg into ton. So the answer should be A. And next, number 9, which of the following processes contributes to carbon emissions in the manufacture of cement? Okay, for cement, it contributes to quite a significant percentage of carbon emissions in the construction industry. And it is due to all of the above. Okay, first of all, this is the calcination of limestone, which is a chemical reaction process. So during this chemical reaction, carbon dioxide will be released. And we need heat for heating up the limestone. So in order to have this chemical reaction to work, we need to provide heat. Okay, so we will probably burn some fossil fuel like coal or oil in order to provide heat for heating up the limestone. Okay, and then after you have the cement, the manufacturer needs to transport the cement from the factory to other construction site. So the transportation of cement to the distribution site will also contribute to carbon dioxide emissions. So all of the above. Number 10, which of the following methods can help minimize the embodied carbon of a building? Okay, for the embodied carbon of the building, it is due to the consumption of material. Okay, so any method that can help you reduce the wastage, reduce the amount of material usage, or maybe help you to recycle, reuse the building material. So all these will help to minimize the embodied carbon. So adopt simple layout. So simple layout can lead to reduction of the building material, design of efficient deconstruction. So when you deconstruct the building, it means that you can revital, or you can collect all these materials for other usage. Okay, and so it should be all of the above. And then 11, which of the following is true about the building material steel? Okay, so for A, steel is the most widely used building material in the world. This is not true. So which material is the most widely used building material? It should be concrete. Okay, not steel, should be concrete. And then B, the energy saved in recycling steel is similar to that in reusing steel. This is not true. Okay, reusing steel will save much more energy, okay, than recycling. Recycling means that you melt the steel and then cast a new steel, but it will use a lot of energy. Okay, but reusing is without melting down the steel, so you will save a lot of energy by reusing the steel. And then C, more than 80% of the steel is recovered from waste worldwide. This is true, okay, because steel is a very expensive material. Okay, so yeah, we will recover the steel as much as we can. Using welded connection in steel can promote easy dismantling and therefore reuse of the steel. Okay, not welded connection, but should be nuts and bolts. Okay, so that you can dismantle the steel and then use it elsewhere. And number 12, which of the following statements is true regarding renewable building system? Okay, renewable building system. A, okay, always produce zero carbon emissions. This is not true. Okay, renewable, like biomass. Okay, biomass is also renewable. Okay, but by burning biomass, it will generate a lot of carbon. Okay, so not true. Renewable building systems are not necessarily low carbon system. Okay, so this is true. The answer should be B. All materials used in renewable building system are carbon neutral. Okay, no, okay, just like biomass. And renewable building system cannot contribute to carbon emissions. Not true. So B. And number 13, in a carbon embedment curve, okay, the MACC, carbon embedment curve or carbon embedment cost curve. Okay, so various emissions reduction projects are ranked from the most cost-effective on the left to the least cost-effective on the right. Each block represents one decarbonization solution. So which of the following statement is true? A, the width of a block represents the annual carbon embedded for the emissions reduction project. Okay, this is true. Okay, the annual carbon embedded. Okay, maybe in ton of carbon dioxide equivalent. And then for B, the height of a building block, the height of a block indicates the total cost of that emissions reduction project, not total cost, but the cost of emissions reduction per each unit of carbon embedded. Maybe US dollar per ton of carbon embedded in carbon equivalent. Or maybe Hong Kong dollar for per kg of carbon equivalent embedded. And C, the area of the block represent the total carbon embedded for that emissions reduction project. Not the total carbon embedded, but the total cost of that project. Okay, the y-axis is what I mentioned, the cost per unit of carbon embedded. Okay, and then the x-axis is the annual carbon embedded. So x-axis multiply y-axis, that would be the total cost for annual carbon embedment. Okay, a positive carbon cost refers to strategies that reduce emissions but also result in net financial saving. It should be negative. Okay, a negative carbon cost, that is when you refer to that MCC curve, the bars that has negative y-axis would be the strategies that result in financial saving. Okay, number 14, what is the primary purpose of using a discount rate in the life cycle cost analysis of carbon emissions project? So for discount rate, it is used for many applications. Okay, usually in the life cycle cost analysis, okay, not necessarily carbon emissions. Okay, maybe life cycle cost analysis for for studying different building design alternatives. Okay, we will also use life cycle cost analysis. So what is the purpose of using discount rate? So it should be B, to account for the time value of money when evaluating long-term costs and benefits. Okay, for A, to estimate future cash flows without considering inflation. So for inflation, we can include it in the discount rate. Okay, so if we include inflation in the discount rate, we may also include the escalation price of a product. Okay, so that would be a real discount rate. Okay, so a discount rate can include or can consider inflation or escalation of price. And for C, to calculate the total emissions produced over project lifespan. So this is irrelevant. Okay, it is not related to discount rate. Okay, and to compare costs of different carbon offsetting technologies, also irrelevant to discount rate. Okay, so B would be the best answer. And then number 15, an automobile manufacturer has been reporting its greenhouse gas emissions for over 10 years. While working on the latest greenhouse gas inventory, the manufacturer realized the emissions from new site for engine testing were being omitted in the inventory in the recent 3 years. Which of the following tasks should be done that can maintain report completeness over time? So the keywords would be completeness. Okay, so when we do the carbon footprint assessment, there are 5 essential considerations. Okay, and completeness is one of them. So here, A, B, C, D, which one is about completeness? So for A, sources with inaccurate data should be excluded from the inventory. So this is true, okay, but it is not about completeness. This is about accuracy, okay, about the accuracy. And then for B, emissions from facilities that have been excluded due to incomplete information should be clearly identified and disclosed in the report. This is also true, but not about completeness. This is about transparency. And then C, the emission sources from all facilities should be regularly reassessed and accounted for. So this is about completeness. Okay, so from time to time you need to assess whether all the facilities have been included in the report. Okay, so about completeness. And then D, same approach should be used to quantify its organizational boundaries over time. So once again, it's not about completeness, although it is true, but this is about consistency. Okay, and then number 16, similar question. An international firm sells its skincare products in 1,000 different shops, outlets, and department stores across the country. It is expected that the greenhouse gas inventory process for this large and disaggregated organization would be very complicated. Which of the following tasks should be done that can ensure the greenhouse gas emissions reporting is consistent to enable meaningful comparison over time? So once again, the keywords is consistent. So A, B, C, D, which of these is about consistency? So for A, the emission sources from all facilities should be regularly reassessed and accounted for. So this is the completeness, okay, whether we have include all the facilities. And then B, sources with inaccurate data should be excluded from the inventory. So about accuracy, and emissions from facilities that have been excluded due to incomplete information should be clearly identified and disclosed. So it's about transparency. And then D, same approach should be used to quantify its organizational boundaries over time. Then this is about consistency. Okay, same approach to use over years. Okay, then you can compare the emissions year over year. Okay, number 17, the parent company A holds 75% of the ownership of its subsidiary company X. Company A has the ability to direct financial policy. So it means company A has financial control over company X. Okay, and then for the greenhouse gas reporting of company A, what should be the percentage of company X emissions to be reported under equity share approach and financial approach? So for equity share, it's very straightforward. Okay, just about how many share that the company owns. So for company A, it owns 75% of the ownership. Then under equity share approach, also 75%. And then for financial control, either 100% or 0. So for company A, it has financial control, then 100%. And then 18, the parent company A holds 75% of the ownership of the subsidiary company X. Company A has significant influence over the operating policy. So it means that it has operational control. Okay, but does not have financial control. So yes for operational control, but no for financial control. And then if you are reporting under operational control, then 100%. And for financial control, 0%. Okay, so remember, for operational control or financial control, the percentage is either 100 or 0. So this 75% is for equity share approach only. Okay, number 19, for an end consumer of purchased electricity, the emissions associated with electricity transmission and distribution losses are reported under which scope? So just like okay, for when I go home, okay, I will turn on the lighting and then maybe turn on the televisions. So I need to pay for the electricity. So I am the end consumer of electricity. And when the electricity is being transmitted over the transmission cables, there would be some transmission loss. And these transmission loss will also indirectly contribute to carbon dioxide emissions. And these would be counted under scope 3. Okay, not scope 1, because no direct emissions within my home, and not scope 2, because I didn't buy those transmission loss. So it would be scope 3. And then number 20, similar question. Okay, number 20, a manufacturing company has switched its electricity provider from a utility that relies on fossil fuel Okay, sorry, this one would be similar to 19, okay, but 20 is different. Okay, yeah, this manufacturing company has switched its electricity provider from a utility that relies on fossil fuels to one that utilizes renewable energy generated by solar panels. If the company's electricity demand remains unchanged, so same electricity consumption, so what impact will this have on its greenhouse gas emissions? So it would be reduced in scope 2. For scope 1, it is just irrelevant, okay, because it is about electricity consumption, okay, not burning of the town gas. So for electricity consumption, it's always about scope 2. Okay, you are buying, you're importing electricity. So although the electricity consumption remains unchanged, but the emission factor will be smaller, okay, because that utility provider using renewable energy, then the emission factor will be much smaller. Okay, and then 21. So number 21 is similar to number 19, okay, also about the transmission loss. An electricity retailer purchases electricity from an independent power company and resells the electricity to end consumers. A portion of the electricity purchased by the retailer is consumed during the transmission from the power company to the retailer. In the greenhouse gas report of the retailer, the emissions due to these transmission losses should be reported in which scope? So this one is a bit tricky. Okay, so the keyword would be purchased it. Okay, so a portion of the electricity purchased by the retailer, okay, purchased by the retailer is consumed during the transmission loss. So it means that these greenhouse gas emissions is due to the purchase of electricity by the retailer. Then it would be scope 2. Okay? And then number 22, which of the following cases would trigger the recalculation of base year emissions in greenhouse gas reporting? So for number 1, the organization acquires a production facility from another company which results in significant change in base year emissions. So acquisition and significant change, then yes, it will trigger base year recalculation. And then number 2, the organization acquires 3 different facilities in different years, and the change in base year emissions is not significant, okay, but the cumulative change is significant. Okay, then it will also trigger the recalculation. And number 3, the organization opens a new production facilities for effective manufacturing process which results in significant increase in emissions. So this is not acquisition, not divestment, not merging of business. Okay, it's only the normal operation of the business. Okay, then it is it will not trigger base year recalculation. And number 4, a significant calculation error is found in the quantification of greenhouse gas emissions by one of the facilities. Okay, when an error, significant error has been found, then the base year emissions should also be recalculated. Okay, and yeah, these recalculations should also be reported, okay, because of transparency, okay, for advising the stakeholders. Number 23, according to the guidelines to account for and report on greenhouse gas emissions and removals for buildings in Hong Kong, co-released by the EPD and EMSD, which of the following types of greenery are quantified as carbon dioxide removal sink? Okay, only for trees which is tall enough, okay, taller than 5 meters and are newly planted, then it will be included or it will be treated as a carbon dioxide sink. Okay, if the trees is not tall enough or if this is not a newly planted trees, then not counted. Number 24, consider 2 approaches to reduce carbon emissions from manufacturing industry. In approach A, the government makes it a policy to use only the predetermined technology. So it is a regulation. Everyone should use a particular technology. And then in approach B, the government determines which technology are cleaner and subsidize their use. So maybe you have a list of technology are available to the business. And then if you choose to use these technology, then you can get some subsidies from the government. Then for approach A, it would be command and control. For command and control, it is mandatory. Mandatory, and the government will specify the limit of reduction, or I should say the minimum amount of reduction for using certain kind of technologies. So no flexibility, and very often for command and control, there is no financial incentive. But for approach B, it is a market mechanism or market-based mechanism. So you have a flexibility. The company has the flexibility to choose which technology to use, and they can also gain financial benefits, financial incentives. And for 25, what is the key criterion in determining if a carbon emission policy is market-based? So it would be B, when it provides financial incentives designed to shape a specific behavior from those responsible for carbon emissions. Like earlier, providing subsidies or maybe carbon tax. So if you choose some clean technology, then you can pay less for the carbon tax. Or maybe emission trading scheme, you may earn money by investing in clean technology. So all of these will generate financial incentives. Number 26, why should carbon tax be used in conjunction with other measures? So for carbon tax, it will allow the government to generate some revenue. So like government can earn money by having carbon tax. But at the same time, it also means that some low-income company may suffer from this policy. So it will be recommended for the government to use those revenue to subsidize or to help those low-income company. So A, carbon tax can have regressive impact, some negative impacts to certain groups of people, and disproportionately affecting the poorer individual. So there should be other policy used together with the carbon tax. Number 27, to ensure the total greenhouse gas emissions would fall, would reduce, then the cap in the emission trading scheme should decrease every year. The amount of credits awarded to the companies in the region should drop every year, such that you can ensure that the carbon emissions will also reduce every year. Number 28, which of the following sentences describe the cap and trade system correctly? So cap and trade would be just the same as the emission trading scheme. Emission trading scheme would be just the same as the cap and trade system. So it relies on supply and demand. So if you reduce the cap, reduce the number of credits, the number of certificates in the market, then reducing supply. Reducing the supply, then the demand will be higher. So it is, and cap and trade or emission trading scheme is market-based mechanism. So basically, every market-based mechanism will rely on supply and demand. It is a type of command and control. Not true. It should be market-based mechanism. it is an excise tax on the producer of raw fossil fuel based on relative carbon content of those fuel. So it would be carbon tax, but not cap and trade. It creates a schedule of fees and rebates to the purchase price of carbon emissions. Okay, this one also market-based, but it is not cap and trade. Okay, maybe some subsidize to carbon reduction. Okay, number 29. Why is it important to integrate carbon management into master planning? So I think this one is like common sense. Okay, so it helps cities to withstand climate-related stress, okay, related to carbon emissions. And then number 2, it supports the reduction of greenhouse gas emissions, okay, something positive, and then related to climate change, related to carbon emissions. And here, it increased the complexity of urban planning. So this is no, okay, this is something negative, then it would not be about the master planning. It encourages urban expansion, irrelevant, okay, irrelevant. And it promotes long-term ecological balance. So ecological balance is about the environment, okay, how you balance the living by the people and the benefits or benefits to the environment, or minimizing the impact to the ecology. Yeah, so this is true. Okay, so the answer should be C. Okay, 1, 2, and 5. And the last question, number 30. What is the main purpose of conducting a carbon appraisal at the master plan level? So it would be to compare the carbon emissions between different development options. So you may have different design alternatives. So which one may perform better? Okay, has lower carbon emissions in a life cycle point of view and so on. So yeah, it is to compare the alternatives. Okay, and then for the short answer questions, maybe we can put 2 along each other. Okay, question number 1. I think question number 1 is easy. I think most of you get the right answer. Okay, a building install a solar panel system for 50,000. So this is the installation cost, the initial cost, which is expected to generate 9 megawatt hour of electricity annually. Given the electricity tariff is $0.5 for every kilowatt hour, what is the simple payback period? Okay, so the simple payback period would be the initial installation cost divided by the annual saving, okay, annual money saving. So the initial cost 50,000, and then 9 megawatt hour would be 9,000 kilowatt hour. So here 9,000. Okay, so maybe you need to understand the unit. So here mega, okay, would be 10 to the power 6. Okay, so divided by 9,000 and then the unit rate of electricity. So the payback period is 11.1 year. And number 2, a building installs a solar panel, okay, for the same amount of money, 50,000, which is expected to generate the same amount of electricity, 9 megawatt hour of electricity annually, and the tariff, okay, same rate. Okay, and number 1, assuming a discount rate of 3%. So this is D, the discount rate, and a study period of 15 years. So here we assume that this solar panel system can operate for 15 years. So you only need to pay in the beginning of the project Okay, and then every year you will save this amount of money. Okay, so for number one, part one, calculate the life cycle cost of the installation. So for the life cycle cost, it will include the installation cost in the beginning of the project, and also any money saving in the coming 15 years. Okay, so this 9,000 multiplied $0.5. This is the energy fees. Okay, the electricity fees saving every year in the coming 15 years. So these are future amount of money, and you have to convert the future money into the present value. So we need to use this equation. Okay, I hope that you still remember how to use this equation. So this AO is the annual saving. Okay, and this equation is for recurring costs. Okay, recurring costs. So if you refer to the notes, you have two equations, one for one-off amount, and then this one is for recurring. So for the electricity fees saving, it will happen every year in the coming 15 years. So it is recurring. Okay, it happened, it will repeat year after year. So we will use this equation. And this is the annual money saving. So here, this is the annual money saving. And D is the discount rate, 3%. And N is the number of years of the study period, which is 15 years. Okay, so you put all these into the equations, and it means that in this bracket, it would be the total saving in the electricity fees in coming 15 years, and these future money would be converted into the present value. So this would be the total present value of money saved due to electricity fees. Okay, and then this $50,000 is the initial cost. Okay, it happened in the beginning of the 15 years, so you don't need to apply the discount factor. So the cost and then minus the total amount of money saved, it would be the life cycle cost. Okay, in the whole life cycle of 15 years, and it is a negative value. So it means that you can save money, you can have some financial benefits by this project. And then number two, additionally, if the emission factors for electricity generation is 0.6 kg carbon dioxide equivalent per kilowatt hour, calculate the life cycle cost per ton of carbon dioxide equivalent embedded. So this is just like the calculation for drawing the MACC, the marginal embedment cost curve. Okay, so in order to draw this curve, we need to calculate the cost of each project for reducing every ton of carbon dioxide. Okay, so in part one, you have the life cycle cost. Okay, you have the life cycle cost, and then if you want to calculate the life cycle cost per kg of carbon dioxide equivalent, then just divide it by the amount of carbon dioxide reduced in the 15 years. So this is the amount of energy generated, okay? And by utilizing the solar panel, okay, then you don't need to burn the fossil fuel, and and you will be able to save the carbon which is emitted due to this amount of energy consumption, right? So the amount of carbon embedded would be 9,000 kilowatt hour multiplied by 0.6, okay, and then 15 years. Okay, so this would be the total amount of carbon reduction in 15 years. Okay, and the life cycle cost divided by the total amount of carbon dioxide reduced. So we have the this value. Okay, and it is a negative value. So it means that you don't need to pay extra. Okay, you will even have some benefits, some financial benefits from this project. Okay, next, question number 3. Here we have to determine whether the greenhouse gas emissions will be counted under Scope 1, Scope 2, or Scope 3. So let's take a look at A. The emissions from a gas cooking equipment which is owned by the organization. So the organization owns that equipment, so it means that it would be within the operational boundary. Okay, and it is a gas cooking equipment. So for a gas cooking equipment, it will generate direct emissions. Okay, so when you burn the natural gas, you will emit carbon dioxide directly within the boundary. Then it would be Scope 1. And then B, the emissions from an electrical space heating unit which is owned by the organization. So just like A, this unit is owned by the organization, so within the boundary. But this is an electrical space heating unit, so it consumes electricity. Then the emissions would be indirect emissions due to the import or due to the purchase of electricity. Then it would be Scope 2. And C, the emissions from a natural gas heater which is rented by the organization and financial control approach is being used. So for financial controlled approach, it means that the organization can have some financial benefits from that facilities. Okay, but for this company, it has no financial benefits. Okay, the company rented, this organization rented the heater, so there is no financial gain through the use of this heater. And the emissions due to this gas heater, so although it is a direct emissions, okay, so within the site, carbon dioxide and other greenhouse gases will be emitted, but it is not within the boundary. Okay, not within the boundary, because this heater is rented by the organization and financial approach is being used, so it is out of the boundary. Okay, then the emissions will be under Scope 3. And next, fugitive emissions of carbon dioxide from a portable fire extinguisher owned by the organization. So it means that this is within the boundary. Okay, within the boundary, and fugitive emissions would be direct emissions. Okay, directly from the extinguisher, we have carbon dioxide being emitted, leaked to the atmosphere. Then it would be Scope 1. And then next, fugitive emissions of methane in the landfill due to the waste produced by the organization. Okay, just like the A4 paper you throw away from your company. Okay, no direct emissions in the boundary, and it is not due to the electricity consumption. Okay, but because of the activities in your company, okay, some methane will be generated when you throw away these waste, these A4 paper in the landfill, and when they decay, okay, it will generate methane. Then it would be indirect emissions and not about imported energy, so it would be Scope 3. And the last one, fugitive emissions of HFC in the central air conditioning system outside the office rented by the organization. So for this part of the air conditioning system, it is outside the boundary. Okay, the organization has no control over the central air conditioning system. Okay, then it is out of the boundary of this organization. So although once again it is direct emissions, but it is outside the boundary. Okay, therefore, also scope 3. Okay, next is about the base year emissions recalculation. Okay, company X divests a manufacturing facilities. Okay, it's about divestment, not acquisition. Okay, it's divestment. Okay, divest a manufacturing facility Y to another organization in the middle of the year. Okay, middle of the year. The greenhouse gas emissions of X and Y from year 1 to year 4 are here. It is given that rolling base year pro rata year after adjustment would be used. Determine the greenhouse gas emissions in year 1, 2, 3, 4. So, first of all, you have to understand that it is X divest manufacturing facility Y. Okay, so X is divesting Y. So it means that Y will not belong to X anymore. Okay, and it happened in the middle of the year. And we are using rolling base year. So you can see that here, you don't need to write down anything because we are using rolling base year. And it means that the base year will be updated every year. And using pro rata, okay, using pro rata, so if it happened in the middle of the year, then half, okay, half of the emissions. And it is a year after. So for year after, it means that we will ignore about this divestment when it happened. Okay, so it happened in year 2, okay, but in the year 2, so we just ignore it. Okay, so in the year 2 report, although this divestment has happened, okay, but we just ignore it because it is a year after. So for year 2 report, we still assume that the company company X own facility Y. So this would be 900, okay, because it is a year after. So we just ignore the divestment in the year 2 report. So 900, 800 adding 100, so 900, and then here 700 adding 120, which is 820. Okay, so ignore the divestment in the year 2 report. And then in the year 3 report, we start to consider about this divestment. And we will consider by pro rata. Okay, so by pro rata, then in the year 2, the divestment happened in the middle. So it means that the company X should be responsible for half of this 120. Okay, so 700 plus 60, okay, would be for the year 2. Okay, and then for year 3, we are using the same pro rata. Okay, so also half, and it would be 750, and then plus half of the emission. So 790. Okay, and then for the year 4 report, okay, for the year 4 report, the divestment has already completed, even for the base year. Okay, for the base year, it is now updated to year 3, and the divestment has completed. And for the year 4, the divestment has also completed. So it has only the emissions from company X, while from facility Y, it would be just 0%. Okay, so it would be 750 and 750. Okay, and then number 5. Okay, calculate the greenhouse gas emissions in ton of carbon dioxide equivalent from purchased electricity of 18,500 kilowatt hour from the Hong Kong Electric, and the emission factor can be found in the last page. So this one is easy. Okay, I think almost all of you get the right answer. So from the HGC, then we refer to this table, and the emission factor is 0.71 kg per kilowatt hour. Okay, but be careful, in the question, it asks you to give ton of carbon dioxide equivalent. Okay, so the calculations would be, okay, the amount of energy consumption multiplied by the emission factor, and you have to divide it by 1,000, such that you can convert the unit kg, kg into ton of carbon dioxide equivalent. Okay, and then the last question, calculate the greenhouse gas emissions in ton of carbon dioxide equivalent. Okay, again, from a heating plant which consumed 2,000 liter of kerosene. The emission factor can be found in the last page. Okay, and you are also given the global warming potential. So for kerosene, it will cause carbon dioxide emission. This one is for carbon dioxide, and then methane, and then nitrous oxide. Okay, so you have kerosene 2.429 kg per liter, and then for methane, this unit, and then for nitrous oxide, this value. Okay, so you have carbon dioxide emissions, and for carbon dioxide, the global warming potential would be 1. Okay, and for methane, the global warming potential 28. For nitrous oxide, 265. And all these need to be divided by 1,000 to convert the unit from kg to ton. Okay, so adding all these would be the total emissions by the consumptions of 2,000 liter of kerosene. Okay, any questions about the test? Okay, if no, then I will first of all give you back the workshop. So there are 12 groups. So maybe each group can find a representative to get back the answer sheets. Group 1. Group 1, anywhere? No. Yeah. Okay, group 1, group 2. 2. Group 3. Okay, group 4. Yeah, 4. Okay. Group 4 and group 5. 5. Group 6. Sorry. Group 7. Okay, and then group 8. Group 9. Oh, group 9. Okay, then how about whoever is group 6? Group 6, anyone? And group 10. 11. Group 11. 11. Group 12. Okay, maybe I have forgotten to upload the marks to the Blackboard. Okay, I will do it tomorrow. Okay, tomorrow morning, or maybe very soon. Okay, I will upload the marks, and for the assessment of the workshop, some of the groups get the perfect answer. So I gave A+. That's the highest grade. All right, and then if you go to the Blackboard, you should be able to find a folder called Revision Lecture on 27th of November. So some of you requested some highlights in the lecture slides. So I know that some of the lectures have many pages. Okay, like 70, 80 pages, and then here I have tried to extract the most important slides. Okay, like so maybe yeah, for the first lecture, I have selected only 16 pages. Okay, so 16 pages out of the first lecture, which consists of like maybe over 50 slides. Okay, so these are the most important slides. But I have to tell you that in order to understand the topics, I will recommend you to read all the slides first, okay, and then maybe for preparation of the examination, then you can go through these most important slides. Okay, these are some highlights. But don't just read the highlights slides. Okay, you may not be able to fully understand the topic. Okay, so all these would be yeah, some most important slides for each topic. All right. Okay, and then for the revision, yeah, it's about the examination, and for the examination, it will be conducted on 15th of December. So please check the examination time period, and you will be given 3 hours. Is it 3 hours for doing the exam? And you have to choose 4 out of 5 questions. Okay, choose 4 out of 5. And don't do all the 5 questions. Yeah, because I will only choose the first 4 questions for assessment. Okay, I will not mark all and then choose the 4 questions with the highest mark. No. Okay, I will only mark the first 4 questions. So choose wisely. Okay, choose 4 out of 5. And then these are some of the most important content, okay, that you need to study. Okay, first of all, about carbon and greenhouse gases. Okay, the significance of carbon in climate discussion. So why we use the term carbon all the time, and what are the primary greenhouse gases as defined by the Kyoto Protocol. And you also need to understand the concept of carbon dioxide equivalent. Okay, and also the concept of whole carbon footprint, which include the embodied carbon, the operating carbon, and the transport carbon. Okay, and the carbon emissions in buildings. So the emission sources. Okay, so in the building, you have so many different kind of emission sources, maybe contributing to embodied carbon, contributing to operating carbon or transport carbon. Okay, so have some background. And contribution of buildings to global greenhouse gas emissions, okay, the material, the electricity consumptions, and so on. Okay, effects of carbon policy on construction industry. So those carbon policy could be maybe carbon tax, or maybe you have some energy efficiency regulations, maybe more and more stringent energy efficiency regulations. And for carbon tax, it means that the carbon intensive material will be more and more expensive. And maybe if you utilize the energy which is generated by burning fossil fuel, also more and more expensive. Okay. And maybe the government may also enforce the use of some carbon emission reduction technologies. So what are the effects of these carbon policy on the construction industry? Okay, and you also need to know how to calculate the embodied carbon. Okay, so I think you can refer to the PowerPoint slides and also some tutorial exercise. Okay, we have some calculations about embodied carbon. And the economic aspect of carbon reduction. So you should know how to calculate the simple payback period, just like what we have done for the test. And the life cycle cost analysis. So once again, just like what you have done for the test. And the carbon embedment potential. Okay, the cost per kg or per ton of carbon dioxide equivalent, okay, the amount of carbon embedded. And you also need to know how to draw the marginal embedment cost curve and what is the definition of some of the components, okay, like the x-axis, the y-axis, what is the structure of the curve, what are the components of the curve, and how to interpret, okay, how to analyze the cost curve. Okay, and next would be the emission scopes. So the definition of scope 1, scope 2, scope 3 emissions, and for each scope, what are the sources of emissions, and how to apply the emission factors. Okay, there are different emission factors, some for electricity consumption, some for burning certain kind of fuel like the kerosene in the test. So you need to know how to apply those emission factors. And calculations of greenhouse gas emissions in different scope. Okay, scope 1, scope 2, scope 3. And what are the factors which will influence the emissions in each of the scope. Okay, regulatory mechanism. So there are different types of mechanism, command and control, and the market-based mechanism. So for the command and control, what is the definition? Okay, what is the meaning of command and control mechanism? What are their characteristics? Okay, some drawbacks or maybe some strength. Okay, advantage, limitation of this regulatory approach. And for the market-based mechanism, okay, same. Okay, what is the definition? What are the characteristics? Okay, and the features. And yeah, for market-based, you can provide economic incentives, and yeah. Okay, and finally, do some cost calculation with or without the emission trading scheme, just like in the tutorial exercise. Okay, calculating the amount of economic saving. Okay, when you have the emission trading scheme. How much money can be saved by trading the credits in the market. And that's it. Okay? So I think you should have enough material and information for the preparation of examination. Okay? So these are the key PowerPoints. Okay, so when you don't have enough time, okay, then you may study these PowerPoints. Okay, but yeah, I hope that you will have the time to study all the slides. Okay? So I think that's it. And I will see you on the day of examination. So good luck. And if you have any question, you can also ask me. Thank you, thank you, thank you, thank you.